So we're going to start with Module 4. Any questions about Module 4? Put it in the chat. Anything you want me to review? You didn't feel confident? I'd like to do some problems in Excel. You guys feel confident? Are you looking? If you have no questions, let me know. Just say no questions. Ok, en la página 25. I spend some time differentiating between the 4 types of problems you'll see. And the idea here is to help you realize that there is a pattern. Okay, there is a pattern. If you couldn't identify which problem you have, it's just easier to answer questions systematically. Okay, so let's look at page 25. Sorry for the scrolling. Close your eyes if it makes you dizzy. Okay, page 25 is close your eyes. Okay, let's do these ones. Actually, I wanted to do these ones because these ones, I put the clave there, but I do not think I solve it. Is that correct? I do not solve it. I put the clave 24, 25, so it's here. So the solution is here. So pretty. Okay, so we'll do page 25, 1 and 2, right? And then page 33. Pick up another one. Page 33. Now, if you haven't studied 5, it's still worth staying. And you can complete your review from the beginning to the end and begin your review for the exam of everything. But it's still worth it. Okay, this is a good one. This is a good one. Yeah, okay. So yeah, 25 is good because I don't believe I have solutions for it. If I go through here, 16, yeah, I stop at 17. I let go and let you try them. Page 7, exercise 7. Let's open another one. Okay. 7. Ready? And the numbering of the pages should be the same if you're in the Spanish notes. We're going to start with the first page on the list, which is number 7. Okay, this is page 7, right? Remembering we did this last class, I told you if it's equals and it's x is from a continuous variable, in this case, x is a variable that is distributed normal with a mean equals to 64 and a standard deviation of 2. And doesn't matter, this information, the bracket doesn't matter, the n matters that it's normal, so we know it's continuous, so a value, the density at a value is always 0. Those are easy points for you on the test if that comes up. All right, so we're going to use the same x here. So I'm going to draw x, and it's hard, always on glass. Should draw x. And I am going to put, so when I solve these problems, initially I draw x, okay? Later on, like I told you last class, only draw the standard and normal curves. But in this case, I can draw x, and I know 64 is here, and 2 standard deviations would be 62. So I draw it. That's in the middle. It's supposed to be in the middle. And we want this area in between. What do we know about 64 and 62? Let's go back to my drawing that I have here. I have it in another place too, don't I? I made one here. Let's copy it from here and take it over. This is what we're using. I'll put it here. So if the mean is 64, then that's at 64, and this is one standard deviation below. So 64 minus 2 is 62. And I know that to find the area between 2, I take the bigger area is all of this. How much is all of this to the left? We talked about this last time. It's right in the middle. It's 50%. So we all know that's 50%. So I can write 0.5000. And I put 4 decimals to remind you that you use the table, right? With 4 decimals as a percentile. Wanted to write 50%. And on this, on the left of this, well, this is 1 standard deviation away. How do you use this chart, the symmetry, and the fact that you have it partitioned this way? to be left here of 1 standard deviation. So it's 68% between. So we're extracting. You have to ignore these other ones. Basically, I guess I can clean it up. What I'll do is I'll clean it. I'm going to clean it up. I'm going to remove all this noise and just look at, and I don't even want this right now. I don't need it. And I can erase all this information, too much information. And there. So that means it's 68% in between. So in outside 1 standard deviation from you are 100 minus 68% of the observations, which is equal to 32. But this arrow tells me, so this means in between. This is a review for many, but bear with me. Not bad to have a review. So this is in between 62 and 64. And I just want to go to the left. So I don't want to talk about all the way outside, like that's what this is giving me, right? It's giving me outside. So I just want the left side. So this must be divided by 2. Okay, so this is before you learn about the standard normal. This is before I introduce the relationship between the any variable that's normally distributed and a standard normal variable. So we did it in a crude way. This is very crude, but it's not a bad thing. It's just this is like a model we can use to solve problems. So I'm going to write it, this is just 32% divided by 2. Questions? So that's that area. So what do I do with that information? This one is 16, this one is 50, and I taught you to find the area in between. It's equal to the bigger area minus the smaller area. So that's 50%, or I'll write it as a decimal. I'm always torn. I just want you to realize they're interchangeable. Minus 0.1600. So the answer is that's one way to do it. The other way to do it is divide 68 by 2. So there's different ways to do this. Yeah, you could do that too, Patricia. I kind of wanted to review this whole this in between thing. So this is also 34. Note you could get the answer by 68% divided by 2, which is also 34%. So there's often different ways to do the same problem. Okay, let's look at the next one, unless you have questions. Lisa.
Professor, we can do either one of the methods for the.
Yes. Yes. Yep.
Permiso,
Yeah, they're
profesor.
both acceptable.
Tengo una duda sobre ese ejercicio. ¿El resultado final es 34% o 16%?
16 es solamente eso here. So this, the 16 is, I'll put it in blue. Let me change the color. Maybe that will help. So I have to take, that one is, 1 minus 68% divided by 2. %. So you need to take the big area, which is all of this, the 50%, and remove this. You're cutting out this slice. You're cutting this out. Like a piece of bread or a cookie. Slice of bread. Both are correct. All right, let's see another one. So the next page coming is 25. Any questions about that? So that is the original method, but then I introduced the standard normal, and it brings us to some of the problems we did last class, the table, okay, and this one. So this is a quiz, a little bit challenging, and we got to watch, like Aritza said, the arrows. I always draw the arrows. So the lovely answer is prepared for you, but let's go step by step together with this one, okay? So in general, there are problems that I give you about the standard normal, and there's problems that I give you about a variable that's normally distributed. This is all for the standard normal for you to practice. So this type of problem, when I give you the probability, this is, I call a type 2 or a backward problem. And I give you the probability and I ask you for the Z score or the X score. So what you have to do is this time you draw always when you're working with when you're working with a backward problem, for the first step, always draw a Z. So we're going to draw Z. Looks similar, right? The difference is that I'm at 0 here in the middle. It's not arbitrary or some other value. It's always 0. And I want to put my pen down where, so this Z means the curve, okay? The curve under the curve. The curve under the curve greater than small z, that's what I want to find. You see, I want to find z. small z, the value, the score, z-score. Where should I be along this line so that 82% are under the curve? Where should I move, left or right? So I want to have, so this left is 50, but I want more than 50 because this is 82. So where do I move? Left. Very good. Okay, so I move here and I'm gonna draw something like this, and I put C here. So my first step is to find where relative to the mean I am positioned. And I can find that answer using the Z table, the Z, the standard normal table. How do I use the table? The table always gives areas to the left. So we need the area on the left. So look inside the table for the area to the left here, the percentile. Even though the arrow goes this way, the table is always on the left. So that's where I can start. So let's go to the table and, well, sorry, let's do 1 minus. So 1 minus 0.8289 is equal to 0.1711. Thank you for confirming. Now we're going to go to the table and look for that value. Take it with me in case I forget. And it's going to be on the smaller table, the negative table, right? The negative z-score. So I'm going to look for this value inside the table, 17. And remembering that as I move from here, the table is like you have to read it backwards to get more area to the left. So it's actually read like this, like this, like this. It's getting bigger this way. Okay, so bigger going down. So 171 is even below where I am. 17. Oh, there it is. Nice, nice, right there. Sometimes it's not exactly there, and we talked about that a bit last class. But this time it's nice right there. And that corresponds with, oh, let me get it right. Negative 0.9 and 5. Negative 0.95. Aha. Somebody wrote 0.95. So there it is. You're going to get it wrong. You're going to get it wrong if you just look up the 89% number, okay? Because you're going to be on the other side. So let's write the answer down first. So this is negative 0.95. I'm going to put it here. So this is negative 0.95. So it's close to 1, negative 1. All right, let's recap. So we want to find where the area is 82, 89. If we look up this number, we're getting this amount. We're actually looking at this amount. The problem with that is the table always gives you to the left. And so if you look up, So if you go in the other direction and you change the sign, you will get the same area. So this is actually saying P, so this is wrong, right? P of Z less than C equals 0.8289. But this is wrong because I want to go that way. All right, so what you have to do is always area to left. Look inside the table for the area to the left, always, if you're going to use the table. And even if you're going to use Excel, and I'll show you that in a second. So we used the information given to get the area to the left and looked it up and got this. And we're finished. We're finished the problem because that's all it asks for, the standard normal score, z-score. If they asked us for x greater than x, we have to do a second step where we find how many, the value where we are about 1 standard deviation below the mean, or negative 0.95. Okay. So this is not the question. I'm going to put an X on it. If you did look up this number, remember that the same answer is if Z is less than and you change the sign, that will give you the same number. So it means if we go and look this up, we get Z equals 0.95, but we need the negative of it for our answer. So negative Z is equal, it would be negative Z equals 0.95. So Z is equal to negative 0.95. That's another way to do it. I apologize if it's confusing, but these will have the same answer. You just have to change the sign. Basically, you're in the wrong place and you have to change the sign to a negative. You're on the wrong side. Okay. So if you change the direction and the sign, you have the same probability. That's the symmetry. That's a result of the symmetry. Okay, let's look at Excel. Ready? I believe I did this in the videos. You can tell me if not. I'm pretty sure. I reviewed today's, but I didn't review last class. Okay, so how do we do this in Excel? You can open Excel. And again, you're free to use Excel if you like it. Some students don't like it. They prefer the table, but we'll take advantage of the fact that it's a distance course and I allow you to use all your materials. We can use Excel. All right, you can see Excel now. And
Yes, I can see it.
Okay, so we're going to hit equals for the formulas and start writing normal. And you see there are some options there. For this problem, which one do you think that we use? Which one feels like the right one to use? You see there's 4 options, like the 4 types of problems I told you that they're going to be. So there's 4 different possibilities. Which one is it? What kind of problem are we doing? What did I say at the beginning? I called it something. Starts with a B. The backward problem. The backward problem or the inverse problem? So which one do you think it is? God, I wrote something. Let me see.
The third one.
Not the third one. Normal inverse, the inverse problem.
Oh, it's just that I saw nominal first. That's why I said.
Yes, yeah, don't worry about that. It's the
Okay,
one of
okay.
the 4, norm dist, norm inver, norm S. What do you think about these ones? So there's 4 there. What do you think it is? Which one? What is the S for? Keep guessing, keep guessing. Okay, a few of you are getting it right. So we're going to do this problem. It's a standard normal problem. So that's the S. The S is for standard normal, and we're doing a backward problem. So we're going to use that one. There. All right, so what does it ask for? All it asks for is a probability, 1 data point. That's just, so what are you going to put in there? What probability are you going to give it so it gives you the z-score? Put it in the chat. What probability should I put in there to get the right answer? So you're giving the probability. Excel works like the tables. It works with the area to the left. So what do I put in there? Take a wild guess. Keep guessing. Area to the left, area to the left, area to the left. Okay, so I gotta project this again. Maybe you didn't write it down. Let me project this again. Area to the left. Uh-huh. I had to show you the drawing. So take a screenshot of that to remember it's 0.1711 is the area to the left. Now, it's if you put the wrong number in, it's okay. You just have to remember the problem that I X'd out is what you're going to get. You're going to get 0.95 and you have to change it to a negative. Okay, so it's got to be the area to the left, just like we're doing with the table, just like Excel. So again, I emphasize any software that you use, you have to understand the underlying assumptions, how they're doing things. It's not enough to put numbers in Excel or Stata or S or SPSS. All right. Okay, so back to Excel. Do you feel wise now? So let's put it in. 0.11, 711, and close the bracket.
I don't know if it's just me, but I'm not seeing Excel. I'm seeing like
Oh, I
everyone.
put the iPad again.
So
Let me do it again. You saw the iPad, right?
Right now, no.
No, but before?
Yeah.
Yeah, I just picked the wrong thing. Okay, I didn't pick anything. You're seeing your cells, right? Excel. So go back to this and we're going to type. I'm going to make the column a little bit bigger. The probability is 0.1711 and close the bracket. And that's it. We got the answer. So let me put the formula beside. That's not it. Let me put the formula beside. What I can do is, again, like last time, is just I can screenshot this and I'll put it on the platform after the video just for you to summarize, what we did with Excel. Okay, so that's the answer to that one. If you put 89, 82, 89, you're going to get, well, let's see, what do you get? You're going to put 8289, or let's put, just going to copy it, Control C or Apple C, Command C in Mac. And we're going to change the number to 89, 8289, 8289. And you get the positive version. Yes, exactly, Adaira. So if you go the wrong way, you have to change the sign. If you draw a picture, you'll keep track of what you're doing. Right.
Thank you.
Okay. All right, so let's do the next one. We're doing all of these, right? Okay, let's do the next one. So this is just exercises so that you know how to use the standard normal. And you can't, this is the most important chapter, or this is the most important module, because we will use it through the rest of the course. We're going to take a pause from it in module 6. We're going to discuss probability for a few weeks. Then we're going to get back into it, right? So just keep that in mind. This is not something you can forget. You need to remember this stuff, learn it properly. So what I want to do is go back to my iPad. Stop share. Share my iPad. Okay, so why don't you guys try this one if you haven't had a chance? Again, the solutions are all there. It's just that right now we're trying them. We're practicing together, bringing those exercises to life. Okay. How in the world do I draw this? I need to have 54%, 5468 between, this means between, but the same value. When I write the negative Z or negative Z and Z, they're the same number. So it's right across like the middle. So I'm going to just make a drawing like a little bit more. Gotta go a little bit more, no, a little bit less, right? Because we know one standard deviation makes 68 and this is just 54. So this is negative Z here and this is Z here. And in between is 0.5468. So what should I do to get the area to the left so I can use my table? Which one should I use? Z, negative Z or Z? Melba, are you okay with, you wrote something there in the chat. Is that okay? It's clear?
Yes, it's clear.
Okay.
It was the same answer.
Okay. Should I use negative Z or Z to look up on the table? Well, I do need to give the answer of Z, but it's the table gives me the area to the left. So I should look up here. What is that on the right there? How much is that? So I'm going to repeat, look inside the table for area to the left. So we're going to do, yes, minus C. So what did we do before to find the area to the left? We did 1 minus 0.5468 divide 2 gives me the area to the left. So they give me the in between, but it's rather useless with the Z table because the Z table works and Excel works with the area to the left. What is the area to the left? 2, 2. Is that right? 6, 6. All right, because I divide by 2, right? Everybody agree? Great. So 0.2266. And I look inside the table for that number, and I'm on the negative, but I have to answer with the positive. So, because the question says look for Z, right? But we're going to do this step first. Let's go to the table and look for 0.2266 on the negative table. Oh, which way? This way. 0.2266. I hope it's a number. 22. Oh, look at that. Very nice. It's right there. Very nice. It makes it easier, right? So this is negative 0.75. Negative 0.75. Negative 0.75. So let's put that. So negative Z is negative 0.75. So Z is equal to 0.75. Let's go to Excel. I'll give you a minute to write it down. If you looked up this number, you would get the wrong answer because that's not the area to the left. Yeah, basically that's what some students would do. Just plug it in, and that's not correct. Okay, so let's go to Excel. All right, you tell me now. Go into Excel. I'm gonna put question 1. And now we're doing Q2. I'm gonna cheat. I'm gonna copy. Oh no, I won't copy. Let's write it again. Norm. So which one do I use? Is it the same as the first one? Same thing, right? Norm S. Okay, so norm
Sí.
S inverse. And then I put here the probability it's asking me for. And that's going to be the area to the left, 0.2266. There you go. Nice. It didn't work. It didn't work. It's capturing the number, not the formula. You're bothering me. Yeah, I gotta do something else. There. Okay. So those were the same. We just had to do a preliminary step. And let's do the third one, right? So to get the positive directly out of this problem, you would have to do what? If you wanted the positive answer right away. Not to confuse you because you found one way, but how could you get the positive answer right away? What would you have to look up? Do you agree we have to make a drawing to answer this question? Like this forces you to make a drawing to be clear what you're doing. If you wanted to get Z right away, you would have to put all the area here, not just 5468. You should put 0.5468 and 0.2266 and get a whole number that will give you the area all the way over to the left. And that's a long way, right? You'd just rather do it this way and give the positive answer. So what is that if you add those together? So you have to be clear in your mind the difference between probability and z-score, because here I have a decimal, here I have decimals. So if you don't understand with the drawing, you're going to be very confused. These are percentages underneath, and these are z-scores. They represent the number of standard deviations you are from the center on a z table or z curve. So this is the z is the number of standard deviations from mu. Okay, you added them for me. 0.7734 looks like the right number. So now look that up. Let's put that in Excel and see, we'll get the positive 0.75 right away. Again, if you like Excel, you can use it. If you don't like it, don't use it. Okay, so I'm going to just do equal norm S inverse and then put in here the number we calculated, 0.7734, and close it. And there you go. Doesn't work the way I want it to work. I have to copy the formula. All right, let's do the third one. So draw, okay, I'll give you a minute. How many of you did this before? Already did this by themselves? How many of you already did this? I'm just curious if I'm wasting anyone's time. Okay. I mean these problems. I don't necessarily mean Excel. I just mean these problems. So I'm putting back my iPad. I'm going to draw this. Me and my perfectionism. That's not so perfect. All right, so there's my set drawing, and I want a very small, this is like 7%, it's small amount. Between Z and 0.5, so 0.5 is, a positive 0.5 is like here somewhere. And zero, remember, is in the middle. Again, I'm using numbers that can really confuse you because 50% is the probability at the middle, but this is not a probability. This is the Z-score. So this is 0.5, where this one is 1 over here, you know, somewhere like that. Let's put a little bit more over. So like 1 is here, 0.5 is there. And between 0.5 and some value, I have 0.0698. How should I find that value? You could probably do this different ways. What do you think? What do you feel like doing first? So don't worry too much if you don't immediately get this. The test won't have questions. This challenge. This is pretty challenging, but we can do it. We can do it together. So where should I start?
You can start by subtracting 1 less the 0.0698.
If I do that, I have no idea where I am though. If I take 1 minus that, what does it give me? Because what I'm trying to figure out is, well, my immediate gut instinct is to look this up, not this one. I want to look this up and see how much area I have here. Because that will help me know if Z is on the positives or Z is on the negatives. Because I know this is 50%, I can figure out in between, and that will help me know where I am. Anyway, if we look this up, this is like an in-between figure, so it's not really on the chart directly. It's not on that table. Okay, so look up this number in the table, and what do you get? So you're just going on the left, right? Because when I give you a Z-score, you go on the left side, sorry, the margin. So 0.5 gives you 6915, okay? 6915.5, because that's a Z. So this is 0.6915 all the way. And then this over here is 50. So how much in between? And you don't look up that number either. It just gives you an idea. Okay, so let me see. Let me leave you with that. Everything is here for you to solve this. I just gave you the boundaries. Be creative. This is more of a critical thinking problem than any statistic problem. I've taken all the statistics out of it because I've shown you the area in between here is 1915. But you're trying to find the position Z that's in between. It's going to have to be because this whole area is 19%, and we only need 7% between 0.5 and Z. So Z is in here somewhere. Z is in here. How are you going to find it? Remember, the Z only has 2 decimal places because it's a Z-score. So what did I do? I took the area from 0.5, which was 6915, and I subtracted off all of this to find the area in between to help narrow down where in the world is Z. So Z is somewhere in here. Okay, so I'm going to make this bigger again. So wherever Z is, it divides these in half so that this area is 0.698, right? All up. This area blue and the Z here let me make it blue. This area should be 0.698. And that's the total area is 0.198, 1915. But I just want this sliver here. So how should I do it? So if the whole thing, if the whole thing is 1915 and this is 0.698, what is the area to the left of Z? Maybe there's an easier way to do this. How much is this one here? How much is this area? So, so 0.1915 minus 0.0698 gives me that area there.
That's 0.1 to 1217. Oh,
7. Say it again.
0.1217.
So 0.217. And what do you do with that number? So 0.1217, add back the 0.5 to get the area completely to the left of this, and that's the one you look up, area to the left. So if you add these together, I did something wrong with my math there. It's an extra 0. So 7, 1, 2, 6. Look up 6217, and that will be the area completely to the left. And that will give you the Z. Oh, I did this right. I never looked at the answer. So I'm going to look up area to the left is 0.6217. So I need the area to the left. I was not given that. I was given the area in between, only this. I was given that this is 0.0698. I had to find where it was first. It was 0.5 starting here, but I need to find where this was. So I found that, but then I need to use the tables, and it's only the area to the left. So this is what I have to look up or use in Excel. So what do I get when I look that up? So this is a very good exercise when you think you've understood everything and you want to test yourself. This is distinguishing between probabilities and Z-scores. And one tool, visual tool, is I always use 4 decimals for probabilities and not 4 decimals for Z-scores. Patricia, 0.3412 is 0.5. Where are you getting that number from, 0.3412? I didn't write that number.
It's 64 divided by 2.
64. Where do you get that number?
68, sorry.
68 divided by 2. Well, this is not at 68. This halfway. 68 is here.
But like from
Divided by
0
2.
to 1, there's 34.1, but from 0 to 0.5, it should be
Oh,
like,
no, it's not half. Because this curve, it's not even. If it was a square, you were right. If it was like this, but it's not, it's curvy, so it's not exactly divided by 2, but it's a good guess. I mean, it's a start. We'll compare it to what we get in the end. So what happens when you look up this? Now I've converted all of this into this. Again, I won't put anything like this on the test, so don't worry. It's just exercise to practice. So it's that curve that makes it so you can't divide by 2, but it's good critical thinking for an estimate. All right, so we're going to go to the table and look up 6217. I'm always getting areas to the left. 6217 will be here. I mean, it's on the positive table. 6217. Oh, look at that. Nice. Now, they don't always match up perfectly, okay? So just warning you. If they don't match up, you're supposed to use the closest one. If they are the same, you average the same values to find the middle or central value. So 6217 is 0.31, and you guys got it. Some of you got it. Or did you use Excel? Which is just fine with me, as long as you know what you're doing. Area to the left. So 0.31. We'll do it in Excel. But notice I couldn't put this whole curve in Excel, right? I needed to reason with the curve. So that's another take away from this exercise that you need to draw the curve and put your values on it. Okay, after this, we're going to take a break. Let me just put it in Excel. And we got to do a few more normal so we can do the other. There's 4 functions in Excel. We're just using the same ones all the time. Oh, no. Actually, no, this will be a different one. Okay, let's talk about that. This is not an inverse problem now. This is just a regular type 1 problem, I call it. Okay, so how do I enter this into Excel? Oh, no, it is a backward problem. What am I talking about? It's another backward problem. They're all backward problems. Q3, it's the same thing. But I'm going to change this to the probability 0.6217. I was getting ahead of myself because I do want to do something else. And then copy there, return, put it here, and this is the formula. And it's 31.31. So notice in Excel, you get a lot of decimal places. You might find that useful. The table we're using is not so detailed. It only has 2 decimal places for the Z's. Good, good, good. All right, let's take a break. Let's meet back here at, do you want 5 minutes or 10 minutes? Put it in the chat. Okay, let's take 10 or 9. So I'll see you at 10:30, okay? Sorry about that. I got carried away texting. All right, I'm back. Let's see. All right, I'm here. Okay, so let's do this now. Any questions? Any questions? Let me make it bigger. So this is page 33. I think someone asked for that. All right, so I just did the inverse problems. I did it by drawing some like different kinds of problems. I mean, they were a little more challenging than usual. More challenging than what's going to be on the test in the last case. And I showed you how to solve those in Excel. So let's do a few other problems. And I'll show you how to use Excel for them. So there are 4 types of problems in general. We know how to identify the backward problem. They give you a probability and you put it in Excel and you get the z-score. Let's try these ones. Let me give you, if you haven't had a chance, a few minutes to do the whole page. Okay, so try the whole page, but I will in 5 minutes or so, I'll do the first one. Or let me know when you're done the first one. Just put it in the chat if you're done the first one and I'll know. If I get like 10 people or 7 people in the chat said they'd finish, I'll start doing the first one. And just do it manually and you can play with Excel a little bit. It's always good to know different ways of solving problems, different tools, so then you can confirm your answer. If you don't have a clave while you're writing a test, you don't have the answer key, you can solve the problem different methods. And if you get the same answer, it's kind of confirming that you're probably doing it correctly if you've done it different ways. But when you're done, just put number 1 in the chat. Okay, some people have written in the chat. So I'm going to do this one and then show you in Excel as well. Okay, so you're going to draw this. No, you're going to say what percentage of pregnancies, so Z is pregnancies, lasts more than 250 days. That's how I know how to write it. We're not Z. Why did I write Z? It's not Z. We're on to X. So now we're going to not just standard normal, we're going to the regular normal distribution problems. Okay, so that's going to make the difference. And X is distributed normal with a mean of 266 and a standard deviation of 16. So what I have to do is in this problem requires me to convert it first into a Z problem. 250 minus 266 divided by 16. So then I can use my standard normal table or Excel to answer the question. Any questions about the arrow and the numbers I'm using? So I get 250 minus 266 divided by 16 is -1. So this is just Z greater than -1, which if I draw it, -1 is here on the Z curve. Okay, so we draw always the Z curve unless we have a question using the 68, 95, 99.7 rule like we did at the beginning of the class. Usually we just draw Z. We don't draw X. This is -1 here. And I go this way. The arrow goes this way. But I know that the table will just give me the area to the left, so I have to be careful if I look this up. So if I look this up as -1, I get this value here. Let me make it bigger. So -1 is this one here, 1587. I'm going to copy it and put it over here. Now where does that go? Where does that number go? Left or the right? It was on this side, right? It's on this side. So let me make it smaller. And so to get the answer, I have to use 1 minus. And I get like what you have, 8413. Very good. So it's 84%. So the chance of a pregnancy lasting more than 250 days is very high. It's 84%. All right, let's do this in Excel. Do you know how to do it in Excel? And then we'll go to number 2. Do you guys appreciate that I'm spending all the time on the normal? Regression shouldn't be too hard, but I do want to say something before we go. Is this all right? Okay, so I'm going to go back to Excel, take a screenshot if necessary. All right, so this is going to be on page, so this was, what page was this on? That was page 24. And now we're on page 33. Okay, so this is Q1. All right, so what formula do I use for this? Yes, good. Norm dist. So let's use that one. So I'm going to click on it. And it asks me the X value, the mean, the standard deviation, and I have to tell it if if I want this cumulative. In other words, to the left, right? Not to the left, but the area under the curve. That's what it means. I have to put a 1 in there. So what do I put for X? Tell me what I put for everything. X, mean, standard deviation. What do I put there? Take a guess. Yeah, so 250. I'm going to do it down here because you can see better. 250, comma, mean is 266, standard deviation is 16, and cumulative is 1 because it's always going to be 1. And then what am I going to get? What should be my answer? What will be my answer? Right. But that's not my final answer, correct? That's just the area to the left. It's always to the left. So my next step is to do equals 1 minus the cell. So that's my answer. Because this was just equal to Excel just gives me the area to the left. So I have to do the 1 minus. So another way we could have done that is put in the -1 and done it with the Z. Which formula would I use for that if I use the Z instead of the X? What formula should I use? Equal, norm. Which one? Thank you everyone for participating. Keep guessing. What formula should I use? It's the same problem. It's not an inverse problem. It's just a standardizing problem, but I already standardized. So let's say I already standardized and nobody has it yet.
The third one, norm as this.
The third one, right. So that's right. It has to be standard normal and the distribution, just a regular problem, not an inverse problem. And here I'm going to put the -1 and I'm going to say 1 and it's going to give me, what is it giving me if I do that?
Mm.
Look above. Again, Excel always gives me the area to the left, so it's just giving me the left side. So this is actually P Z less than -1, but to get the answer, P Z greater than 1, -1, which is what I want, what do I have to do? So we already standardized, and I just trying to do this a little bit faster. Not faster, but I was showing you the other way without doing a new problem. So you just do 1 minus. I didn't write that here. I should write that. I'm doing the 1 minus. I should keep all the formulas on it. Okay, so I need to do 1 minus to get the answer, to get the right side. Which was the question. Okay. So we've used 1, 2, 3 formulas. There's one left. One left, and that's going to be the next problem that we do, the second problem. Any questions so far? I said I'll post this. I'll post this in Moodle. All right, let's do. All right, let's do number 2. So let's solve it and then we'll put it in Excel. All right. Okay, so an army reports the distribution of head circumference among soldiers is normal approximately with this mean and standard deviation. The army wants to provide custom-made helmets for soldiers whose head circumference falls in the top 2.5%. If I'm given a percentage, this is an inverse problem. Okay, I'm given a percentage and I'm supposed to find if eventually you want to find X given the percentage. So as I've explained to you, the only time that you draw X as a distribution is when you do the first set of problems way back here when we did this sort of thing here, okay? But otherwise, we are always going to draw the Z. And so that's what I'm going to do. And I'm going to say that the the position of 2.5% top is there. That's the top 2.5%. And I want to know how many standard deviation that is away. So this is my step one. This is a backward problem. However, it is a backward problem finding X, not Z. So I call it a type 2 X problem. Don't worry about the label. So basically there's 4 problems. Okay, so what we have to first do manually here is because the tables only give us the left side, we need to know the left side that corresponds to 2.5, and we know that's going to be 97.5 on this side. So we're going to look that up in the table, and that will give us the z-score, how many standard deviations we are away. So we're going to go to the table and look for 975. We've done this before on the positive table. And we look for 975, remembering always to the left. We start, so 975 is 975. Oh, it's right there. Nice. 1 point. Wait, 1 point. Let me make it bigger. Now that I found it. So it's nice here. 975 corresponds to 1.96, right? So you can get used to that. That's going to come up a lot in the chapters to come or the modules to come. So as 1.96. So this is going to be like, this is what we want. But then we find Z is equal to 1.96 standard deviations. And then with that, we convert in step 2. We say X is Z standard deviations from the mean. And we fill it in 1.96 standard deviations above the mean. Standard deviations are given as 2.8. From the mean is 57. And you add it together and you get, you guys got numbers for me, 6249. 6249 centimeters. Okay, now let's do this in Excel. Take a note of it and tell me which formula will you use. So do you guys feel better about the normal distribution? Good. We've done every page, I think, of the notes. You have lots of problems still to work on. So let's go to Excel and see which one we use. Okay, so we are on question 2. And which one should I use? Kevin, you put too many together. Sally says the third one. 1, 2, 3. So we could use those, but we don't have to. We can just use right, Miss Sale. The second one. We didn't use the second one yet. So the second one is when you have a regular distribution, not a standard normal, but you're doing it backwards. And look at this. It's going to do everything for you. you give it the probability. Now, which probability should we put in Excel? 97.5 or 0.025? Which one should we put in? Always the left, right? Always on the left. So it's going to be probability is point. So that's just a limitation, it's a delimitation of the software. 0.975 goes there, and then we put the mean 57, and we put the standard deviation 2.8, and we don't have to say the 1 because that's only for the other two. And that's it, and we are going to get the number. Do you believe it? There you go. Okay, so I'm going to write that function out. I'm going to copy it. And this was the probability that X is greater, we can just write it like this, than 2.5%. No. No. It's going to be probably XX and is greater is equal to 0.025. That's what it's answering. We could also do this with the standard normal with the first step. We could also do this with the first step. Well, we would have to do the first step. So if this does everything for us right off the bat. Okay. Right away. Gets everything done. So that's a handy tool to check your work. How else can I write this? I can write PX less than X is equal to that's what we did too. So the original question was greater than, but then we converted it to be left because the table, sorry, Excel uses the left side. All right, so not a lot of you have finished Module 5 or done Module 5. I just want to show you one thing in Module 5 because I was reviewing my videos and I think they're thorough, they're good. I spent a lot of time, not a lot of time, but I spent time in Excel. So I just want to show you how you can use your calculator. Half of you bought your calculators or you have the app on your phone. I want to show you how to do those problems very quickly, and then we're going to go for today. I think I answered all the questions that you gave me today. We're done with normal distribution. We didn't have time to study for the exam, but you're going to study for that, and you're going to send me problems. If you want me to do anything in the week to answer your questions, send them to me, put them in the forum or email them to me. Or if you put them in the forum and I don't respond, let me know there's one in the forum and I can answer them. But I do feel like you have all the resources. You just have to find the time to review them. Okay. So you guys got that. I'm going to take a screenshot and post that up after the class in the video. And, what I'm going to talk about is the calculator. First, I'm going to show you on the iPad. So we're going to go to 5, module 5. And I want to just say something quickly. All right, so there's a detailed explanation of all of this stuff with the video, 3 hours. I think it's quite good. Not to, brag or anything. I just mean that I think it's thorough. So this is done. And then I discussed these in separate videos below that you should watch if you're confused. I have a video of each of these pages, this one and this one. I talk about how to make a line because this is all regards to a line. So you should do that this weekend. I think, stop the normal distribution review and just start this weekend with the regression. So you can spend the week with the problem review. And essentially, these are all the questions you need to be able to answer for the exam. There's 9 of them. So again, you'll see the pattern as you're solving problems. And then I stop here. I don't do anything beyond that. But what I have in here are some problems for you. All right, here. So what I've done here is I presented data in 2 different ways. This is, we can call it, this is financial data. So it has a special name, ex post historical data because it's over time. But in general, it's different from the other set of data because all observations are equivalent in information. They have the same amount of information. And here, this other set is really showing you the data, but as a weighted. So every observation represents a possible state of the world. This is a discrete distribution, and it's indicating that economic circumstances or the economy could be in a boom, normal, or recession state. So that's just an example, but you could have different states of or different possible outcomes, and there's just 3, right? In reality, there's infinite possibilities, right? The multiverse, infinite possibilities on top of infinite possibilities, but I'm just using 3 here. So so this is actually, if these are going to happen, then what I'm assuming is that these represent the population, and I have the same statistics above, but as well, same equivalent. I don't know how to say that. The similar statistics, let's say the analogous statistics, but as Greek letters to represent that these are parameters. So what I do with this is I want you to first, we have a few minutes, okay. So what we're going to do is enter this data into our calculator as pairs. If you remember, I showed you the calculator for entering one set of data, but now we're relating 2 variables. And we can get all these statistics, you won't believe me till you see it, all of these statistics out of your calculator very easily. All right, and that can help you as well and guide you in your learning. So let's do that. How many people, okay, I already know you guys have, half of you have the calculator. You can do this in Excel as well, but today I just want to spend a moment talking about the calculator, doing it for you and show you how to enter that. Okay, so we're going to enter this data. Do you remember how to put data in stat mode? You remember what we press? So if you don't have this calculator, again, you can buy it for your smartphone and then it'll go onto, well, it's on an iPhone, but you can also get it on Android. You can get an Android version for free, but it works a little bit different and it crashes. But if you want it for free, you can also get it on the iPhone. And if you get it on there, then you can actually open it in your tablet, just letting you know. All right, so how do I do it? How do I enter into stat mode? Adriana said second 8, close. First, we have to put the data in. So we go second data. If you have another calculator, you could figure out how to use it too. Basically, entering data will be a data key, or it'll say sigma. It'll have the symbol like this one. It'll look like this, something like that, or data. So you can enter the data like in a spreadsheet. So you're going to hit second 7, and I have something in there, it looks like. So I need to clear my worksheet. Second clear work. Now it's clean. Any calculator you have, you could probably find a video on how to use it in YouTube too. So I'm going to enter these values. I can enter them as decimals. I can enter them as percent. Just be consistent in what you do. Let's put them in as percentage. I'm scared. Let's put them in as decimal. There's only one place where you have problems by if you do it one way or the other, and I'll just use decimal, so there's no problem. 0.15, enter. 0.3, enter. So you're entering them across. Now we're on the second pair. 9, enter. 18, enter. Oh, see, I already forgot what I was doing. Decimals. So 15, 30% in decimals. And then 0.09, enter. 0.18, enter. So I did the second pair. Now I'm going to do the third pair. 0.1, enter. And 0.2, enter. I can do it again if this is too fast. The fourth pair, 0.075, enter, down. 0.15, enter. I'm using the arrows. And the last one, fifth observation, is 0.08, enter, down. And then 0.16, enter, down. And that's it. So I review my data to make sure I did it right. Okay. And now I do second 8. And what does LIN stand for again? I asked you before, if you remember, what does LIN stand for? You don't remember? Linear. It's to make the line. So that's LIN is for linear. That's what it means. These are going to be the linear regression estimates. So that's basically a summary of this module. LIN for linear regression. Good. I guess there was a delay in the response. Okay. So now we're going to scroll down and see the results. So you scroll there. What does that mean? What's n equals 5? That's called the sample size, right? The sample size. And then what's this? That's the average of X. Got to be careful because there's two. Yeah, the mean or the average. Yeah, the sample mean. Sample mean. To be specific, it just uses the data, sample mean. And now we scroll down again. And what do we get? We did talk about this before, so you should be having a deja vu experience because we did do this before. The difference is that we have two variables now. So this is the sample standard deviation for X. And what's this? It's a standard deviation, but it's a different standard deviation from this standard deviation. So this is the sample standard deviation. To calculate, it divides by n minus 1. So it divides by 4 instead of 5 in this case. This one is the population standard deviation. This will divide by 5. It assumes that that's all the data there is. Okay, and that's not correct in this case. So the user needs to know what they're working with. Are they working with a sample or a population? In this class, you will most always work with I guess I'm just leaving it open to possibilities because there might be something in the textbook that gives you a population, but it's all sample usually, okay? But you need to know this for practice, for reality. Okay, so now we're going to go for the Y's. That's the mean of Y. That's the mean, standard deviation of the sample Y. And we have also the population standard deviation of Y. And remember, because we're dividing by a bigger number, Population standard deviation will always be smaller than the sample one. Okay. Okay, we're going to keep going. What's going to come next? Should I let you try and enter all those? Do you need more time? Let me know if you need time and I will slow down. No time? Need time? Anyone? Okay. Okay, a bit more time. Oh, you know, I forgot to pause the video for that 10-minute break. Oh, well. Just realized that. It's raining over here in Atorrey. Nothing new. So happy we didn't get the storm that went through the Gulf Coast. Does anybody want to see me enter the data again? Are you going to work on it yourself? Okay. All right, so I'm going to scroll down and I see A is 0 and B is 2. So what are those? What's A and B? And finally, what is R? So these are the linear regression estimates. There's other values here that we aren't using, but they also help you calculate different statistics. So from the top, the sample size, the statistics for X, the statistics for Y, and then I have the linear regression estimates. A, if you've done the review or you're going to do the review, is the Y-intercept of the line of best fit, the line that fits closest to all the points in the scatter plot of your data. And B is the slope relationship, how you get from one, well, it's basically the slope of the line. So it tells you the proportional relationship between the variables and how good it is to go from one to the other. So this is saying that if the X variable goes up 1, the Y variable goes up 2. So for every move of 1 unit in the X variable, Y increases by 2. So if the X variable goes up 10, how much does the Y variable go up?
20.
Exactly. It's a doubling, always a doubling in the relationship. Now, how good is this relationship? The slope tells you the relationship, but how good is this relationship? How reliable is it that you can just double? And you can see it here, right? This is just double. It's perfectly double. Every value is double. It's always true that it's double. How reliable, therefore, is an estimate in this range, you know, these years over these values. So these are different years. It's always double. And this is all the data we have. Maybe we want to make estimates for the future. And to make that kind of a call, you know, you can just use the data in the range and say, okay, well, if we think things are going to stay relatively the same as they did in this period of time, I can predict that if the S&P 500, the measure of X, is something, the returns on this company's stock, that's what these variables are. So S&P 500 is a measure of market performance, a measure of how the stock market's doing, reflecting the robustness or the productivity of the, or the what's the word I'm looking for? The performance of the stock market and the performance of the economy in general. And this is telling us that it's always going to double. But how good of an estimate is that? Well, it looks like this is perfect over this period and with these values. So it's not hard to want to use as long as you know that the circumstances haven't changed so much. Making an estimate within the range of these values, so from the low end 7.5 to the high end around 15%, you could predict that if the S&P 500 is something, you can just double it to know how the stock returns will be. This is like, these are really high, double. This is reflected, this relationship and the accuracy or the predictability or the usefulness of this relationship is captured in R. R tells you how reliable that relationship is. An R of 1 means perfect. Perfect positive relationship. When one goes up, the other one goes up. When one goes down, the other one goes down. So it's nice when everything is up, but we don't have any negative values here. But we would call this a sensitive relationship because if the performance of the economy is negative 10% in returns for investors in abroad or like a mutual fund or EF, what are they called? Anyway, and then in a fund that broadly captures the stock market, how would this firm do? If this one is 10% negative, what's this one going to do? It's going to be double, negative 20%. So that's not good. Okay, so that we refer to this as a sensitive relationship because the slope is high, like a 2 is high, 5 is higher. It's very sensitive or risky. Okay, so that's in the context of finance data, but in general, what we've got out of this are all these statistics we calculated. Our calculator got the means for both, the standard deviation for both, and the R for both. So we got all this data. And I have many ways of calculating R, but you can get it out of your calculator very easily for 2 variables. And we also got this. This is the slope here. So the formula for the line, which you're going to review if you don't recognize what I'm talking about, is A plus BX. This is the statistical line. We put a hat on it because it's just predictions. It's not like the regular mathematical line. The regular mathematical line, runs in both directions. It runs always. So if you were to plot this data, you could see the scatter plot and you would see that the data points would just go perfectly like that between X and Y. And so making a line between them will be perfect. All the dots would fall on the line. And R in this case would be positive 1. All right, so all of these come right out of your calculator, and as scary as this might be to some people, it's very easy. You just got it out of your calculator. It tells you how good it is or what a good idea it would be to use B to predict Y from X. These are all, you'll see, you get one statistic from others. The only one the calculator doesn't give you directly is the covariance. But if you see here, you can get the covariance too. All you have to do is what? How could you get the covariance from your calculator? Thank you, Patricia. She did the graph in Excel. So yeah, I do Excel a lot in the video, so you can work with Excel. I just wanted to show you the easy way to do this with your calculator for a few values.
Your calculator give a different standard deviation from what Excel gave me, but
It's very similar. It should be very similar. Let me see
low
what I got.
number and also the R.
Unless I put a value in differently. 60.
Okay, have them
It's
right.
the
And
same.
X.
Bye. Yeah, it's 6000601 1. Okay, it's 6. So, it's okay. It's the same. It's a matter of the decimals, how they store the decimals. If you did Excel step by step and you round it, you're going to have a different answer.
I think I saw the population standard deviation and I got it all wrong.
Yeah.
But yeah,
The population standard deviation, you're going to divide by 5 instead of 4. All right, let's finish this one and then we're going to go, right? Oh, we're over time. Yeah. So let's finish this one. So how would I get covariance out? I could take R times the standard deviation of X times the standard deviation of Y and get covariance. So I can get all these statistics in under a minute. And I just wanted to show you that to make it look less ominous as you work through this unit, all right? The idea of using Excel and visualizing is good, but don't forget our first principles in statistics. Statistics is about averages and relative measures. The mean is an average, the standard deviation of an average, the covariance is an average. I talk about the covariance on the video. And the correlation is an index made up of standardizing the covariance. The slope
is the
is,
convergence
Hmm?
on the intercept of the graph?
What'd you say?
Is the convergence the same as the intercept?
The covariance is not the intercept. No, the covariance is, it's like the variance. So the variance, you know how we use the variance to get to the standard deviation? That's what the covariance is. It looks like this is the variance, right? Remember? And then we take the square root to get the standard deviation. And the covariance is just doing it with the other variable. I explain all this in the video. You'll understand better. But this one, you don't take the square root of. Why can you not take the square root of covariance? Does anybody know? We never take the square root of the covariance. Thank you, Naru. We never take the square root of the covariance because it could be negative. Okay, so the covariance can be negative. The B can be negative. So you can't take the square root. But the variance will always be positive because you're squaring about the values if they are negative. So do not square root this. But we can use it to get an idea if the relationship is negative or positive between the variables. But what I do next, or what's the convention in statistics, is to standardize it. You divide it by the 2 standard deviations and you reduce it to an index R. And I will explain all that in the videos for you. So you guys check out the video today while you're fresh, take a break, have lunch, or tomorrow, and then you'll get through this quickly. It's not a big unit. I can talk about it at the beginning of next class, and then we can do some review problems, and then I'll open the test at 1 o'clock. You shouldn't be able to ask me questions from 1 o'clock, from that time to the test ends. So try and get all your questions in before 1 o'clock on Saturday, okay? Okay. Any last questions for me? Thank you. You're going to be fine. The result of covariance on this, okay, so I would take on this one, it would be, okay, R was 1, so that's easy. SX was, oh, I gotta go get it from the calculator. So, SX was 0.03008. I can take 5 decimals. Keep it easy. With the calculator, I could also store values, but I won't go into that right now. 0.03008 and then multiply by SY 0.06016. Here I said 5, which I'll make it 7. Oh. And so you'll get the covariance when you multiply those. So I'm gonna do that again. I'm gonna store SX in 1, and I'm gonna store SY in 2. So store 2, and then I'm gonna recall 1 times recall 2, and that's so easy. And that's my covariance. It's a positive, and it's close to a number that I don't recognize. That's the problem with covariance. I don't know what it means. I just know that it's positive. It's a positive relationship. But I can't take the square root of anything of it. So that's why we don't use it. And we standardize it. If I divide by those, I'll get back to 1. So covariance is just like the variance is a way to get to the standard deviation. Covariance is a way to get to know that it's a positive, and it's a way to get to R, because all I do is standardize it to get R, and R will always be between, it's an index between -1 and 1. How do I know it's an index? Why do I call it an index? Because I'm taking the units of the problem and I'm dividing by the units of the problem. So if this is percentage squared, because it's going to be percentage times percentage, and this is percentage and this is percentage, I'm dividing percentages by percentages, and all the units are gone. So it's just an index between -1 and 1, and I interpret that. So go back, if you're not sure what I'm talking about, go back to module 3 and watch the video on scatter plots. Okay, and then get into this. All right, you're going to be okay. Take a break. Have a good lunch. The sun is up. It's always up, I know, eventually, but the storm is gone. Bye. Have a great weekend. Be in
Bye.
touch. Ciao.
Bye.
Bye.
Permiso, profesora.
Sí.
Sí, para confirmar, ¿usted subirá una copia en español del examen?
Si lo quieres, sí, puedo prepararlo. Ujú.
Ok, vale.
Sí, gracias, Aritza.
De nada, buen fin de semana.
Buen fin de semana, bye.